Hi everyone, this is Kiran from InPixon. I am a statistician and technical associate handling technical queries, demo, training on Systat software. Today, I'm going to give a small demonstration on Systat software, how Systat software is useful in data analysis and graphing. Which and all the data analysis features we can able to perform by using Systat software, which and all the graphical features we can able to generate by using Systat software, and what are the additional advanced features are there for analysis and graphing. So these are the things I'm gonna discuss in this session. Before that, I would like to give a small introduction to the Systat. Systat basically a statistical data analysis and graphing software. Here we mainly concentrated on the data analysis features. Nowadays, in analysis tools, we can see there is a model concept. Model concept means if you want an advanced module in a package, you need to pay extra for that. Suppose if you want additional features in the package, you need to pay extra for that. So all those things, all those problems are not available in this software because from basic to advanced, all the features you can see in the single package of the Systat. And not only the analysis, in data visualization also, you can generate 2D, 3D, high quality, publication quality graphs for your research and for publication. So let's see how user-friendly it is for data analysis and graphing. When you open the software, this is the overview of the software. Here, interface is divided into three spaces, three windows. One is workspace, secondly, the view space, and the bottom one is a command space. And the workspace contains all the analysis and graphical examples. Over 700 inbuilt examples you can see here, which helps you to understand how exactly the analysis output is generating and how the graph is generating. And the secondly, the view space is divided into 5 pans. First pan containing recent files, whatever the data command output you are generating, that is automatically saving here. Second, the theme pan, where you can set the theme of the program theme. Suppose if you want to see a interactive statistics related analysis and a graphical feature in the menu drive one, you can just set a program as introductory statistics. Likewise, if you want to see a medical statistics related analysis and graphical feature in the menu drive one, you can set a program theme as medical statistics. So, but I just keep default option, default theme to see default analysis and graphical option in the menu drive one. And the fourth pan in the view space is did you know pan, which gives hint about the options in the software, and sketchpad is regarding the rough work. And the third one, the bottom one, is the command space where you can enter the command for analysis and graphic. So this package is integrated with both menu driven and command interfaces for analysis and graphic. So what about a data editor? Under file menu, the first option is new option, where you can open the new data editor to enter the data, and you can open new command and output. I'm going to show you the data editing properties. This is the data editor. Here you can enter data manually, or you can copy paste from the external source. If you enter numerical observation in the column, by default, it is showing variable name as variable one. And if you enter non-numerical observation in the data editor, by default, it is showing the variable name as variable $1. This $sign indicates this particular variable is a string variable. I wanna name this particular variable. For that, or I wanna quickly name this particular variable. So how to perform that? Just keep a cursor on that particular variable, right click on that. You can see several options here. The first option is variable properties, where you can perform variable editing. You can name the variable whatever the name you're giving here, that is displaying in the column header and in the analysis dialog box. And you can't enter the lengthy name here because analysis dialog box not considering the lengthy name. but you want to enter the complete name for this particular column. For that, another option is there, that is variable label, where you can enter the lengthy name up to 250 characters. Whatever name you are giving here, that is going to be displayed in the analysis report. And the numeric string and categorical type of variables you can enter in the data editor, and you can enter normal, exponential notation, and data and time observations. Also, you can enter in the data editor. So the variable now created for this column, variable name is created. Suppose I want to create multiple variables column, name the multiple columns simultaneously. For that, there is a default option is there in the bottom, variable view, where you can name multiple columns, and the same variable editing options are displayed here. And you can recode the categorical variable also here. Value label option is there, where you can value the labels. So which and all the formats supporting Systat software? Again, under file menu, the second option is open, where you can open saved data files, saved command, and saved output also. I'm going to show you which and all the data formats you can import into this software. You can import Microsoft Excel, SPSS files, SAS transport, Minitab, Statistica, Stata, JMP, DBase, ASCII, ArcView, Lotus, Diff, StatView. These are the formats are easily supporting into the software. And you can import the database also, and you can import the business objects also. And another thing in this software is, if you keep a cursor on any option, you can see the bubble help. This bubble help describes that particular test option, that particular feature. That feature is for what. So this is one of the unique feature you can see in this package. So under edit menu, you can you can fix the issues in the output editor, data editor, and graph editor. When you click on options under edit menu, you can customize the graph under graph option, and you can change the style of the data, and you can change the style of the output also. And under view menu, you can change the view. Suppose if you want to see the maximum data editor, you can display full view screen, full screen, and you can bring back that workspace and command space again into the interface. And under data menu, you can see different type of data management features. The first four options are regarding variable properties, and under transform, you can perform scientific transformation also, like mathematical, date and time, statistical, multi-case. These are multivariable transformations. If you select any category, you can see the functions which is coming under that function type. This is for computing the new variable by applying the transformation into the existing variable in the sheet. Not only the transformation, scientific transformation, you can perform the coding also. You can record the categorical variable. You can categorize the continuous variable also, and you can rank the variables for non-parametric analysis. You can standardize or normalize the variable also for parametric tests, and you can trim the variables as per proportion, and you can sort the variables in ascending and descending order. And merge files is to merge the multiple data sets in a horizontal and vertical way, and you can display it in the single data frame. And you can generate the group-wise summary, group-wise analysis, and graphical results also by using this by groups option. And in this software, you can generate the experimental designs in by two options. There one is a wizard option and classic option. Let's go through that feature. Let's see how user friendly it is and how it works for generating, and how easily we can generate designs for analysis. Under utilities menu, The option is design of experiment. You can see the wizard and classic option. The wizard option is to generate the designs step by step for analysis, and classic is to generate the designs in single step for analysis. I'm gonna show you how to generate the design step by step for analysis. Now I'm going to generate a simple, completely randomized design, which is also called as one factor ANOVA design. You can generate these many designs under factorial, general factorial, box center, Latin square, Taguchi, Blackett, Berman, and responsive designs like box Blanken, central composite design for optimization, and optimal mixture model additional designs you can generate. So I'm going to show you the CRD, how to generate simple one factor design or complete random design. Just keep general factor design option as it is, and a type of design is full factorial, and the complete block design it is, and number of factors design of course one, and keep this option as it is because only one factor, and the number of levels in the factor is 5. And next, save the, so display the factors. So 0 to 4, 5 groups are there in the factor, and save the design in the file. Just give it as name CRD and save it. Yeah. So any replication in the design, in my case, there are 3 replication. So I just next. So this file sheet is not active now, and this is not randomized design. We need to randomize it. So I'm just set this data active, and I'm going to generate one random sample to randomize this design. So let X is equal to uniform of 0, 1. Sorting that random sample and cut. So now this design is the completely randomized design with replication 3. So likewise, you can generate randomized block design, Latin square design, split plot design for analysis. So what about generating the design in single step? That is a classic option under experimental design option. So again, under utilities menu, design of experiment. Second option is classic, where we can generate designs in single step. I'm gonna show you now 2 cube factorial design. 3 factors, and each factor has 2 levels. So 2 levels, factors are 3, and no replication, randomize that. We need to save it like CRD, how we displayed in the data editor. I'm giving a factorial design. So this is the 2 cube factorial design for analysis. You can, likewise, you can generate the designs for analysis. The main thing in this experimental design is this saves our time by entering the factors for response or dependent variable. Then what about other features under this menu? You can calculate the probability for discrete and continuous distribution, and you can calculate the sample size and power for these many tests. So if you have any doubt regarding any test option, you just click on that particular test. In that dialog box, there is a question mark in the bottom left corner. When you go there you can see the example. Suppose I want to see the sample size and power for PAT-T test. So I just display that, and this is the output, how it is generating for PAT-T test, we can see. And there is the power curve for sample size calculation, and this says not only for this sample size and power calculation, software automatically generating the result supporting plot for every analysis. This is the another unique feature in this software. And under utilities menu, you can calculate the numerical expression also, and you can get the file information, and you can record the command also. Suppose if you have any doubt regarding any test or any graphical feature, you can start record that, and after that, if you perform any analysis or graphing, that particular analysis and graphs code, the commands are automatically saving in this command space, and you can see that in the future. So this is regarding utilities menu. And what about the graphical features? What are which and all the graph executing features are there? What kind of what in what way we can generate the graphs? So I'm gonna show you the graphical feature now. We can execute the graph quickly by using this graph gallery option. When you click on that, you can see the different type of graph templates for quick graphing. Suppose I have one categorical data. I'm gonna import one inbuilt example, which is available in the software. That is survey 2. I just click open. So I'm going to quickly graph some variables. So I'm going to select one graph option. That second option is a 3D pyramid of means. I just click OK. So this items create 3D pyramid mean. I'm selecting some variables for plotting. So yes, 3D pyramid for mean. So this is how it is generating. And I'm gonna show you some basic and advanced editing features. What are the additional features are there for graph in the graph editor. You just right click on the graph editor. There you can see some options over here. The first option is properties for the basic editing. If you want to perform any element, you can display the percentage on the chart or use median instead of mean or labels. So you can label this also like this. And uh, right click on the plot again. You can animate the plot also like this, and you can spin the graph also to see the graph in different angle. And you can save the graph in these many formats also. Windows it ends meta file, EPS, PS, JPEG, bitmap, TIFF, GIF, PNG. In these formats, you can easily save the graph. And what about other executing graphical features? Graph executing features. You can generate the graph by writing the function also, and you can generate the pie chart, bar 2D, 3D bar chart, stacked bar charts, 3D bar chart for mean, median, count, and line 2D, 3D bar charts, line charts, and different type of histograms also you can generate, like gap histogram, frequency polygon, fuzzy gram, and dot histogram also you can generate, and box plot, distribution plots like density function, probability plot, quantile plots, summary charts also you can generate. And another unique feature in this Systat is you can generate a scatter plot matrix directly without performing correlation analysis. In other software, what happens? You need to perform correlation analysis to get scatter plot matrix. And multivariate plots like parallel coordinate display, Andrews Fourier plot, icon plot also can generate, and mapping function also you can perform. And you can add multiple plots also in the single frame graph page or in the single window. These are all the 2D, 3D graphical features you can see in the Systat software. Then what about the analysis features? So let's see the elements, and let's see the properties for basic to advanced analysis, which we can see in the software. So I'm gonna show you. Firstly, we can see basic statistics and row statistics. This basic statistic is to generate the descriptive for the column variables, and this is for the row variables. So this is so you can generate the summary statistics for both the column and raw data, row wise variables data. And you can fit the distribution for discrete and continuous distribution also. I'm going to show you an example how to interpret this one fitting. The same way, I'm going to show you with an example only. I'm taking one fitting. This is exponential distribution. So here we fitted exponential distribution to the one example, inbuilt example. So how to check whether that fitted distribution is best fitted, exponentially distributed or not? How to check that? We can check by this chi-square test p-value. It should be greater than 0.05 level of significance. Yes, here it is 0.335, which is greater than 0.05 level of significance, which says the fitted exponential distribution is best fit, or it is exponentially distributed. We can say like that. And we can perform the categorical data analysis by using this option. These are the different types are there. Under 2A, we can perform these many tests. Pearson's chi-square test, age corrected chi-square, feature exact test to compare the proportion, and odds ratio to measure the association between exposure and an outcome, and use Q and Y relative risk tests are all the tests we can categorical 2x2 subtable tests we can perform. And we can perform Cochrane Mantel and Zell tests for 2x2 by K data case, and correspondence smart correspondence analysis are the advanced categorical data analysis features we can see under this table. And log linear model also we can perform to check the interrelationship among the variables in the especially for the questionnaire data. And we can perform non-parametric tests also. These are the tests for the data which is not following normal distribution. And critical values is nothing but non-parametric approach of the one-way ANOVA analysis. And we can not only the more than two groups comparison, we can compare two independent groups samples also. That is Mann-Whitney test, which is a non-parametric approach of the independent sample t-test. And we can perform geometry test, Flinger-Wolf test, two sample Kolmogorov-Mindro test, and median test, Wilcoxon sign rank test, which is a non-parametric approach of the PAT-T test, and Friedman ANOVA, it's a non-parametric approach of the repeated measure ANOVA, quiet test, one sample Kolmogorov-Mindro test, Anderson-Darling, and these are all the non-parametric features we can perform. And we can check the normality for the multiple dependent variable, multivariate data also. Under basic statistics, also you can see the normality checking option. One is for the univariate case, another one is for the multiple dependent variable case. Usually, for the single dependent variable, we are checking Shapirovic test. If p-value of the Shapirovic test is greater than 0.05, then we can say that data follows normal distribution. And what about the comparison test? Under hypothesis testing, you can compare the mean, variance, correlation, proportion. Not only for the univariate case, you can compare the multivariate case also. This is like a one sample t-test for univariate case, and this is for like a two sample t-test in a univariate case. This is one sample hot-link t-square test and two sample hot-link t-square test under multivariate mean case. So I'm going to show you one hypothesis testing for two independent samples. For that, I'm going to import one inbuilt example again. That is crops. So crops data is selected and just open. I just don't want these first two variables. Yeah, here I have index data because here grouping variable in one column and corresponding variable is the response or the yield variable for this group. In a raw case, what happens means group 1 and group 2 are in the different columns. So I want to see the effect of this variety or the grouping variable over yield dependent variable. Or I want to compare the this group 1 at group 2. So consider these groups are from different population. Of course, we need to perform the independent sample t-test for this case. The hypothesis for the independent sample t-test is under null hypothesis. There is no significant difference in between group 1 variety and group 2 variety. And under alternate hypothesis, there is a significant difference among group 1 and group 2. So let's go through the analysis. Under analyze, hypothesis testing, under mean, two sample t-test. So you can analyze both kind of data. I have an index format here. Variety are the grouping variable. Yield is the dependent variable, and you can change the confidence also, but I just keep 95% confidence limit. I'm gonna check the p-value in 0.05 level of significance. So I just click OK. Here we got a result. You can see the result supporting plot in the bottom, and the result hypothesis also you can see here. Under null hypothesis, there is no significant difference among the sample means. There is significant difference in the sample mean under alternate hypothesis. So here we got a result of both unequal variance and equal variance case. Unequal variance means this is for the unequal group varieties, unequal sample size in the groups. And this is for the equal sample size or equal variance case. So what is the p-value? Both are same, which is greater than 0.05 level of significance. So here our null hypothesis is accepted. And here we need to interpret there is no significant difference in between group variety 1 and group variety 2. And graphically, the result supporting plot also says that variety 1 and variety 2 not have any significant difference. And what about the correlation? We can perform simple correlation, canonical correlation. This is to check, this is usually doing for the reliability data to check whether the selected variables are reliable or not. And Cronbach's, sorry, this is not for reliability analysis. This is to check the canonical correlation for canonical variable. And this is for the reliability analysis, Cronbach alpha, to check whether selected variables are reliable or not. I'm going to show you which are the correlations we can perform for continuous data. We can perform these many correlation tests, and for distance measures, we can perform PATIS, QSK, Euclidean distance, and CT test. And for rank order data, non-parametric correlations, these are the non-parametric correlations we can perform. And unordered data, pi, Grammar's V, contingency, lambda, so this we can perform. And this is for the binary data, these many correlations we can perform by using Systat software. And what about the prediction methods? Which are all the regression features we can see in the Systat software? Under linear, we can perform simple linear and multiple regressions by using least square option. You can build the best model by using best subset regression, and polynomial is a nonlinear regression up to any number of order you can fit a polynomial degree you can fit into the data. And we can perform Bayesian regression, ridge regression also under linear. And this robust regression is advanced regression technique. This is for the outlier data. So this is gonna, if you fit robust regression, that is going to delete the outlier in the data, then applying the regression into that data. And this logistic regression is to predict the binary level dependent variable, and this multinomial regression also we can perform. Conditional discrete choice regressions we can perform. And under binary logistic regression, you can generate the quantile table of 0 to 99% also. There's an option available under binary logistic regression dialog box. And under probit regression, in a probit model, you can generate a quantile table of 25%, 50%, 75%. And these are all about univariate case. And we can perform multivariate regression also. That is a partially square regression technique. I'm going to show you how the result is generating by using one inbuilt example. That is a continuous data. I'm taking our word. So this, yeah. So for an example, partially squares. So I'm taking some dependent variables, three dependent variables, multivariate regression I'm doing now, urban. So I'm going to see the effect of urban over population 1983, 1986, and 1990. So I just click OK. Here we got a result of multivariate regression. So here we can see the regression for three dependent variables. Simultaneously it is generated, and separately we can see all three dependent variables p-value is greater than 0.05 level of significance here, and only 46.3% of total the variation explained by the factor for three responses. Urban explains this variation explained for the this one, three responses. And we can see analysis of variance next option. Here in single option only, you can perform one-way ANOVA, two-way ANOVA, three-way ANOVA, and multivariate ANOVA, nested ANOVA, ANCOVA, repeated measure ANOVA. Every analysis ANOVA features we can perform in single option only. I'm going to show you one two-factor ANOVA analysis or a two-way ANOVA analysis by using one inbuilt example. I'm taking one inbuilt data, that is two-way ANOVA data I'm taking now. So I just click OK. Yes, let's see how the analysis report is generating for two-way ANOVA case. So here drug and disease are the two factors. We're going to see the effect of drug and disease over this response or this dependent variable. Drug has 4 levels and disease has 3 levels. And there are two hypotheses. One is for drug and one is for disease. If p-value is greater than 0.05 level of significance, when there is the null hypothesis for the drug is accepted, then we can say there is no significant difference among drugs. And if here also, if p-value is greater than 0.05 level of significance, then we can say there is no significant difference among disease levels. So let's see how the analysis report is generating. Analysis of variance. First, we have to estimate the model. Drug and disease are the factors. And this third variable is the dependent variable. And another unique feature in this Systat software is no need to specify the variables for the interaction effect p-value. By default, this Systat automatically generating the two factors interaction effect p-value. So I just click OK. Here we got a result of two-way ANOVA analysis. Only drug differs significantly because p-value is less than 0.05 level, and disease and drug disease interaction effect p-values both are greater than 0.05 level of significance. So here we need to check the significant difference in between the drug levels because drug not followed the null hypothesis assumption. So go to the analyze again. We need to perform the pairwise comparison now. So specify the variable for pairwise comparison. Usually we are doing Tucky test. Just click OK. Here we got a result of pairwise comparison. Between drug 1 and drug 2 levels, there is no significant difference. And between drug 3 and drug 4 levels also, there is no significant difference. Only these two pairs accepted null hypothesis of the drug for drug. And there is a separate option for multivariate ANOVA also. We can perform repeated measure ANOVA also in this same option. And in general linear model option, we can perform nested ANOVA also. And but here we need to specify the variables for the interaction effect p-value. But here we no need to specify the variables for the interaction effect. And under mixed model, we can perform split plot analysis, linear mixed model, hierarchical linear mixed model, mixed regression also. We can perform for both hierarchical and multivariate case. And discriminant analysis is one of the multivariate technique. This is to perform the linear combination of canonical variable, which is best separating or discriminates the grouping variable. We can check. And cluster analysis also, hierarchical clustering, K clustering, we can perform. And factor analysis also. I'm going to show you the factor analysis. The methods like PCA, iterated principal axis, maximum likelihood we can perform. I'm going to show you the principal component analysis. For that, I'm using the our world data, which I already imported. I want to see some way. I'm going to perform the PCA for some variables. I'm taking some variables from that our world data for analysis. 5 variables. These 5 variables are highly correlated variables. Usually, we are performing PCA for multicollinearity data. So here correlation is also selected. Principal component analysis is selected. Eigenvalues is 1 and pairwise deletion. Display the sort loadings and extend results. And rotation, these type of rotations we can perform. And I just want an eigenvector. I'm saving that. And another thing is in every analysis dialog box, you can see the resampling option also, where you can perform bootstrap. Now I'm continuing with the principal component analysis to find which is a unique component, how many are the unique components explaining maximum variability in the data. So here we got a result and only 2 components explaining maximum variability in the data, and the total variance explained by those 2 components is 98.8%. Graphically, scree plot is the best plot to predict that. We can see scree plot and biplots as a result supporting plots. Here you can see only 2 components are above the eigenvalue 1. Then advanced factor analysis like confirmatory factor analysis also we can perform to confirm the factor structure. And we can see the different type of time series features also. You can graphically check seasonal and a trend in the series, and this many type of correlations we can perform. If you have any series trend, you can transform the series also to make it stationary. And exponential smoothing and ARIMA, these 2 model options are so there to forecast the future. And Arch and Garch models also you can fit into the series to check whether fitted models are best fitting series or not. And man-candle trend analysis test we can perform. Fourier transformation also we can perform under time series feature. And under advanced, you can handle the missing value data by missing value analysis and quality analysis techniques also we can perform. Control charts also we can generate. Process capability analysis to compare the process capability and process performance. And parametric, non-parametric survival analysis also we can perform. Non-parametric is Kaplan-Meier test to compare the survival function of the groups to see whether it's significant difference among the survival groups. And Cox regression, Cox stratified model to see the effect, whether it has a significant effect. Covariate has significant effect, we can check. And we can perform 3 types of optimization by using response surface method. We saw the optimization designs in under experimental design. So I'm going to show you how to optimize the single response variable. For that, I'm going to import one inbuilt example again. That is block CCD. So I'm just open that. So here yield is my response and time and temperature are the factors, and this is the block variable. So I want to see at what time and what temperature this yield is maximal or minimal. So I'm gonna perform the optimization now. Under advanced response, firstly we need to fit the second degree polynomial. So the time and temperature are the factors, and block as block variable, and model is yield. response. Okay. So here we can fit it, we can see the lack of fit here. The second step is to optimization. So go to the optimize option. Yeah, we can see three type of options here. Ridge, this is for the saddle surface data. Here you can fix the aim. If you want maximal, you can fix maximize target aim, or minimize also. You'll get a different type of minimal points. And at a disability analysis, you can check the overall disability. If a overall disability is 1, then you can say the multiple responses are simultaneously optimized by the factors that you can interpret. So I have only one single response variable, so canonical is the best one. For that, just click OK. Here we got a result that the optimal response is 82.137, where time is 86.861 and temperature is 176.672. Graphically, contour and surface plot, we want to check that time as x variable, temperature as y variable, and contour is generating now. You can see graphically 82 maximal, where yield is maximal over here. And the another plot is a surface plot. So then the path analysis, here also you can see advanced path analysis feature. Ramona is an advanced feature in this Systat package, and we can perform conjoint analysis also, a Shepard diagram, different type of regression like linear monotonic types of conjoint analysis we can perform. Multidimensional scaling, perceptual mapping, polar scaleogram analysis, and item analysis also we can test, and signal detection analysis, spatial analysis, and decision tree. This is like a regression technique. And under quick access menu, you can see frequently using statistical analysis and graphical features. Add-ons also there for quality analysis and Monte Carlo method. And under help menu, you can, as I told before, you can see the contents help and demo help. So if you have any doubt regarding any model, you can just go for the tutorial also. File, open, browse, and suppose if you want to know about cluster analysis, just click OK. Now you can see a small demo help for cluster analysis. So this is regarding the data analysis and graphical feature of the Systat software. Hope this video helpful for you. Thank you so much.